If you look deep into the night sky, you see stars. And if you look further, you see more stars, and further galaxies, and further more galaxies. But if you keep looking further and further, eventually you see nothing for a long while. And then finally you see a faint, fading afterglow. And it's the afterglow of the Big Bang. Now, the Big Bang was an era in the early universe when everything we see in the night sky was condensed into an incredibly small, incredibly hot, incredibly roiling mass. And from it sprung everything we see. Now, we've mapped that afterglow with great precision. And when I say we, I mean people who aren't me. We've mapped the afterglow with spectacular precision, and one of the shocks about it is that it's almost completely uniform. 14 billion light years that way, and 14 billion light years that way, it's the same temperature. Now, it's been 13 billion years since that Big Bang, and so it's got faint and cold. It's now 2.7 degrees. But it's not exactly 2.7 degrees. It's only 2.7 degrees to about 10 parts in a million. Over here, it's a little hotter, and over there, it's a little cooler. And that's incredibly important to everyone in this room, because where it was a little hotter, there was a little more stuff. And where there was a little more stuff, we have galaxies and clusters of galaxies and superclusters and all the structure you see in the cosmos. And those small little inhomogeneities, 20 parts in a million, those were formed by quantum mechanical wiggles in that early universe that were stretched across the size of the entire cosmos. That is spectacular. And that's not what they found on Monday. What they found on Monday is cooler. So here's what they found on Monday. Imagine you take you take a bell and you whack the bell with a hammer. What happens? It rings. But if you wait, that ringing fades and fades and fades until you don't notice it anymore. Now, that early universe was incredibly dense, like a metal, way denser. And if you hit it, it would ring. But the thing ringing would be the structure of space-time itself. And the hammer would be quantum mechanics. What they found on Monday was evidence of the ringing of the space-time of the early universe, what we call gravitational waves from the fundamental era. And here's how they found it. Those waves have long since faded. If you go for a walk, you don't wiggle. Those gravitational waves in the structure of space are totally invisible for all practical purposes. But early on, when the universe was making that last afterglow, the gravitational waves put little twists in the structure of the light that we see. So by looking at the night sky deeper and deeper, in fact, these guys spent 3 years on the South Pole looking straight up through the coldest, clearest, cleanest air they possibly could find, looking deep into the night sky and studying that glow and looking for the faint twists, which are the signal of gravitational waves, the ringing of the early universe. And on Monday, they announced that they had found it. And the thing that's so spectacular about that, to me, is not just the ringing, though that is awesome. The thing that's totally amazing, the reason I'm on this stage, is because what that tells us is something deep about the early universe. It tells us that we, and everything we see around us, are basically one large bubble. And this is the idea of inflation. One large bubble surrounded by something else. This isn't conclusive evidence for inflation, but anything that isn't inflation that explains this will look the same. This is a theory, an idea that has been around for a while, and we never thought we'd really see it. For good reasons, we thought we'd never see killer evidence, and this is killer evidence. But the really crazy idea is that our bubble is just one bubble in a much larger, roiling pot of universal stuff. We're never going to see the stuff outside. But by going to the South Pole and spending 3 years looking at the detailed structure of the night sky, we can figure out that we're probably in a universe that looks kind of like that. And that amazes me. Thanks a lot.